Okay, here's warm-up 10.3. So this first problem, I called these bike gear problems because a lot of times it's a word problem. You can imagine they'd make it bike gears, gears on a bicycle. So I advise my students to cut this quadrilateral here up into a rectangle and a right triangle. So a common mistake that I see people do is make so the cut is the dashed line. The dashed line wouldn't be there to begin with. But people will make their what I call cut like that to cut this quadrilateral up. But then you can see this figure below the pen would not be a rectangle, right? It looks like it would be a parallelogram instead. So you'd want to cut it up like this, okay? The idea on these problems is that this is a tangent line here, this line going across the top. So that means I know that these would have to be right angles, right? And these would be right angles too, but then that's not going to work there. So that right angle is supposed to go for this whole thing, for that little slice up there and that bigger slice too. So I'd want to cut it like this. And then if you just say that you cut this across so that this is perpendicular, then we've got a right triangle down there, but we also got a right angle here, which means that this would also have to be a right angle. So B, this is the correct way, right? This would be the incorrect way. Okay, so then we're going to actually solve the problem on number 2. So let's see. We're solving for x. I need the distance between the center of these two circles. Now, what I can do is use the property, some of the properties of rectangles. One of the properties is that the opposite sides are congruent. So hey, if the top of this rectangle is 30, that means the bottom is 2. This is also 30, right? Also, if the right side is 8, the left side is going to be 8. Okay? And now that's going to be very useful to have that 8 there, because now I can find this little gap, right? 8 plus something equals 10, so I know then that this has to be 2. And now I'm in a position where I can use this right triangle to solve for x, because it's a right triangle where I know 2 of the 3 sides, and that means this is going to qualify for the Pythagorean theorem, right? So I'll do my work up here because I don't have space down there. Pythagorean theorem looks like this, where A and B are the legs and C is the hypotenuse. Now be careful, a lot of times I'll see people put the right angle right down there, which would make 30 the hypotenuse, but that's incorrect, right? My right angle is actually at the top of this triangle. So that means the hypotenuse is going to be the x in that triangle, not the 30. It's a little bit hard to tell just looking at it, but if you do your work correctly, it's not going to be the one attached to the center of the big circle, okay? All right, so my a and b are the 2 and the 30 in either order. I'm just going to say 2 squared plus 30 squared. And then the c would be x. And I'm going to solve this for x. So 2 squared is 4. 30 squared would be 900. And I've got 904, okay? If that's what x squared equals, I still want x, so I'm going to take the square root of both sides to get rid of that square. So now x is going to equal the square root of 904. I'm not going to bother putting that in simple radical form because I'm asked to find this to the nearest tenth. So I'm just going to put it in a calculator to get a decimal approximation. Let me put my calculator over there to avoid the glare. So I've got square root of 904. To the nearest tenth, that's about 30.1. And there we go. So it makes sense. It's more than the 30 because it has to be the biggest side in this triangle. It's just a little bit more, but it's more. Okay. All right. On number 3, we're going to use that same principle, the same idea that a tangent line, when a line is tangent to a circle, it's going to be perpendicular to the radius that it connects to. In other words, this is a right angle. Okay? So hey, I've got a right triangle again. Okay? I can set this up with the Pythagorean theorem, but wait a second, I don't have anything to put in here. But wait a second again, because the radius of this circle is marked as r. So this is going to be r as well because it's the radius of the same circle. R for radius, get it? Okay. All right, so then when I'm setting this up with the Pythagorean theorem, be careful with the hypotenuse. The hypotenuse is not 25. The hypotenuse is going to be r plus 25. Sometimes I see people write 25r, but don't multiply those. We want to add these 2 segments together, right? This is the segment addition postulate. So that is going to be my hypotenuse, okay? So now I'll set this up with the Pythagorean theorem. Okay, A would be either R or 35. I'll use R. And then 35 is my other leg. And when I square the hypotenuse, we want that quantity squared. So I want R plus 25 squared, okay? Now, be careful here. This isn't just this. You can't just square the R and square the 25 because we're squaring a binomial. So you need to think of this as R plus 25 times R plus 25. Okay? So I'll start simplifying here. Let's see what 35 squared is. I forget. 1225. Okay? And then on the right side, I'm going to want to FOIL this, right? I'm thinking first, outer, inner, last. So first, R times R is R squared. Outer, R times 25 would be 25R. Inner, 25 times R is 25R. And last, 25 times itself is going to be 625. Okay, I can see I'm going to be running pretty low on space here, but that's how it goes sometimes. Okay, so I'm going to combine these. Also, I want to combine the R squareds, and something pretty nice happens when let's say I wanted to move my R squareds all to the left. Well, I'd subtract R squared here, and I'd have to do the same thing to the other side. And I just got a gift because the R squareds just disappear then. Okay, so now I've got 1225 is going to equal 50R plus 625, and this is not looking so bad all of a sudden, right? I'm going to want to subtract 625 to start getting the R isolated. And I'm definitely out of space here. Here I'm going to move all the way up there. Okay, so let's see. 1225 minus 625 puts me at 600. Okay, and then I'll divide by 50. To get the R by itself, divide by 50, and I've got 12. So the radius here then would be 12. All right, that's the end of the warm-up, and I'll see you next time.